This video goes over examples of independent events. And independent events are two events that are independent of each other if the occurrence of one event does not change the probability of the occurrence of the other event, which means that this statement is true here. So the probability of A and B occurring is equal to the probability of A multiplied by the probability of B. So example 1 here asks us to find the probability of throwing 2 7s in a row with a pair of dice. So that would be 7 and a 7. Our chance of throwing a 7 the first time we roll the dice is 6 over 36. And then we pick up the dice, roll them again. We have another 6 out of 36 chance of rolling a 7. So our total chance of rolling 2 sums of 7 with 2 rolls and 2 dice would be 1 over 36. Our next example is drawing a card and rolling a dice. So finding the probability that a diamond is drawn and an even number is rolled. So probability that we have a diamond and an even number. So let's look at the chance of drawing a diamond first. So a diamond is one suit, which makes up 1/4 of the deck. So 13 out of 52 cards. And then we're going to multiply by the chance of rolling an even number on a dice, which is 50% or 3 out of 6. Multiplying those together is going to give us a 1/8 probability of getting that combination. Example 3 looks at chips used in calculators. And a certain type of calculator has chip A and chip B. And both chips have certain probabilities of being defective. So what we want to know is the probability that both chips are defective. This is something that manufacturers try to minimize. So this is a useful statistic to have when marketing your product or determining the effectiveness of your manufacturing process. So if we have both chips are defective, these events are independent, so we can multiply together the probabilities. So 10% chance for chip A times a 20% chance for chip B. So that means 0.02 or 2% chance that both of those chips are defective. The next thing that we're going to investigate is if chip A is defective and chip B is not. So we've got our chance that A is defective, 10%. Now we need our chance that B is not defective, which is 1 minus the chance that B is defective. So here I would have 1 minus 20%, which is going to give me 80% or 0.80. Therefore, my probability that chip A is defective and chip B is not would be 0.08 or 8%. Should fill in here, defective, B is not. Our next situation is neither chip is defective. So this would be the probability that A is not defective and B is not defective. So we're going to multiply our chance that A is not defective, which is 1 minus the probability that A is defective, which would be 90%. And then we're going to multiply by the chance that B is not defective, which we already found out above. Multiplying those values together is going to give us 0.72 or 72% chance that both chips are not defective. Okay. The last example that we're going to look at is the situation where at least one chip is defective. So there are 2 ways to do this. One is you could start by saying this. So at least one is defective. You've got 3 possible situations. You have the one where A is defective and B is not. You also have the probability where A is not defective and B is. And then you have the third situation where they are both defective. So A is defective and B is defective. Now, right off the bat, that looks like a lot of calculations to me. I'm going to explore using the complement property, where I can say that my probability that at least one is defective is equal to 1 minus the probability that they are neither defective. So that none are defective. So that's a little bit easier for me to subtract. Plus, I've already calculated that value. And I should make sure my notation is consistent here. So let's say 1 minus the probability that A is not defective and B is not defective, which I've already calculated, which is going to give me 28% chance that at least one is defective. If you check using the direct counting method, you will also get 0.28. Good way to verify that you're actually getting the correct answer.